How do Polyglot XSS Payloads bypass cross-site scripting prevention? Imagine a single piece of code that can slip past many security checks and still do harm. That's what Polyglot cross-site scripting payloads are designed to do. They are crafted to work in multiple web contexts at once, making them tricky to block. Unlike normal payloads that target just one place, these combine syntax from HTML, JavaScript, and URL, encoding into one clever snippet. This means if a filter blocks one part, the payload can still succeed in another. Web browsers and servers use different parsers for HTML, JavaScript, and URL. Polyglot payloads exploit these differences by blending syntax so that the code is valid in all these environments. For example, a payload might look like a valid HTML tag, but also contain JavaScript code that runs when interpreted. Or it could be encoded in a way that tricks filters into missing it altogether. Because of this, even strict input validation can be bypassed if it only checks one context. Content security policies, or CSPs, are headers that tell browsers what scripts are allowed to run. Attackers use obfuscation and mixed-case keywords to evade these rules. For example, writing JavaScript instead of JavaScript can trick pattern-matching filters. They also use encoding tricks like URL encoding or HTML entities to hide malicious parts. This makes it hard for simple CSPs to catch and block these payloads. Another reason they succeed is because developers and security tools often don't know exactly where user input will end up in the code. A single payload can be effective across multiple contexts, making testing and prevention more difficult. Traditional filters that escape or sanitize based on expected input can be fooled by the clever combinations in polyglot payloads. They use comments, string delimiters, and escape sequences to confuse these filters, allowing malicious code to slip through. From a backend security point of view, it's clear that relying only on generic input filtering isn't enough. Proper security means applying context-aware output encoding. For example, encode HTML special characters when inserting data into HTML and escape JavaScript when inserting into scripts. Using frameworks that handle this automatically can help. Also, setting strict content security policies and avoiding direct insertion of user input into executable code are key steps. Regular testing with polyglot payloads can reveal vulnerabilities that simple filters miss. In essence, these payloads bypass defenses by being valid in multiple parsing environments at once. They take advantage of how browsers interpret code differently and use obfuscation to evade pattern-based filters. For backend developers, this highlights the importance of precise, context-specific security measures. Relying on just filtering or escaping isn't enough anymore. You need to understand how your application processes input and output, and enforce strict encoding and policies accordingly.